continuing on. The dog weights in pounds for a sample of 3 of the most popular breeds of dog are shown. Now, we've already entered our Desmos data in. X1 is Labs, Y1s are German Shepherds, and Z1s are the Golden Retrievers. It wants us to create a distribution in order to see if there is any skewness. So what we need to do here is add a box plot. X1, box plot Y1, and we're going to offset this one by 5, and box plot Z1, and we'll offset that one by 10. Now we got to scroll out so we can see them. Alright, here are 3 box plots. So as we can see, they're all relatively center. Mean X1, mean Y1, mean Z1. Alright. So if we take a look, all these graphs are pretty symmetric. So now we have to select what conclusions we can apply. The average weight of each breed is about the same. Yeah, between 67 and 68 pounds, it's about the same, 100%. The weights of all 3 dogs breeds are very close to their means. Well, not all 3. If we take a look here, we have to define close, but the German Shepherd goes all the way down to about 52, whatever its minimum is, and its maximum is over 80. So, no, we can't take that one. The weights of the German Shepherd vary more than the other breeds. That would be true. German Shepherd has a bigger range. On average, Golden Retrievers weigh much more. No, on average, they're about the same. The means of the weights differ by less than 1.5 pounds. All right. So, yeah, they are different by less than 1.5. The weights of the Labrador Retriever and Golden Retrievers are generally closer to their means than the German Shepherds. And that is true. If we take a look, we have our top and bottom ones are closer to their average. They're not as spread out. The upper quartile, all right, next up. Oh, wrong side. Here we go. Number of high school boys and girls in the 100,000 participating in tennis from 2001 to 2015 is shown. They constructed a histogram of the data. As we can see from their histogram, the distributions have more on the left than right. Yeah, so it's a skew, or more. They have more data on the left. Both distributions are skewed. And from we see their averages in the center, these midpoints, they're really high, and then we have more over here and almost nothing on this side, more over here and almost nothing on this side. Entering the box plot data, we get the same thing here. We see that they are skewed. Their left-sided boxes and tails are larger. This gives the data a negative skew. Since they have a skew, we need to use the 5-number summary. Continuing on to the back. The upper quartile of the number of boys that participated is 160. It says while the minimum number of girls that participated is 160. This means that we're only 160,000 or more boys participated in tennis for 25% of the year. At least 160,000 girls participated every year. So, yeah, the boys' Q3 mark is the minimum of girls, so definitely the girls have more people playing tennis than boys. We can conclude that many more girls participated in tennis from this time. All right, next up, the number of raffle tickets sold by Darius and McKay each day are shown below. So on Desmos, we added that data down here for X2 being Darius and Y2 being McKay. It says use a graphing calculator to construct histogram or box plot. We're going to go with box plots. They're just way easier to see skewness on. Box plot X2, box plot Y2. All right, and then we're going to come back in. Let's offset this one by 10. Oh no, that's height. We want offset. So if we take a look, Darius is way bigger on the left than right, where McKay is the opposite, way bigger on the right than on the left-hand side. So both of these are skewed. Where Darius has a negative skewed and McKay has a positive skew. And so to compare, we need to do 5-number summaries. So that's stats X2. Oh, not like that. And stats Y2. The median number of tickets Darius sold is much higher than the median number McKay sold. All right. Darius's median is 10. McKay's median is 15.5. That is false. Darius's median is less. The median number of tickets Darius sold is the same or as the lower quartile of McKay. Lower quartile is Q1. Darius's median's 10. McKay's is Q1. That is true. The data from Darius sales is spread over a wider range. Keyword on this is range. So Darius has a range of 29, 30 minus 1, where McKay has a range of 22. So yes, Darius has a wider range. The median number of tickets each student sold was the same. Absolutely not. 10 is not equal to 15.5. The fewest number of tickets each student sold in a day was 1. Both of them have a minimum of 1. That is correct. The upper 50% of Darius's data spans from 10 to 30. So this is saying from the median to the max. So median to max, 10 to 30. Correct. That's true. And then the upper 75% of McKay. So upper 75 means we're going from Q1 to max. Q1 is 10 and max is 23. That is also true. Thank you so much. Finally got this note